This lesson is 5.5. This is product to sum identities. So what this means is if we are given a product, if we have sine of alpha times sine of beta, for example, or sine of alpha times cosine of beta, or cosine of alpha times cosine of beta, or cosine of alpha times sine of beta, we can rewrite these as an addition or a sum instead of as a product. Right now it's times and we want to change it to plus. So we're saying product to sum. So for sine of the first times sine of the second, that's equal to cosine of the first minus the second minus cosine of the first plus the second all over 2, or times 1/2. So these are all written here. For example, if you want to go through them, you're going to need to know these. You're going to need to apply these in different situations. Sum to product is very similar, except we have the sine of alpha plus sine of beta, or sine of alpha minus sine of beta, or cosine of alpha plus cosine of beta, and cosine of alpha minus cosine of beta. And then we are rewriting these as a product. So make sure you look these up, make sure you do some problems with these, and you become familiar with how they're actually applied. You probably will be able to use these or reference these equations on your quiz or your test, but you'll still need to know them. So also in this lesson, I'm going to do a quick review of all of the Chapter 5 identities we've gone over. So this would be a good thing to fill out. See if you can do it before I tell you, but I'm going to fill it out here anyways. So we have all the trigonometric identities from Chapter 5. So let's start with the Pythagorean identities. That's where we have sine squared theta plus cosine squared theta is equal to 1, as we remember from that triangle. And we remembered that if we divided everything by sine squared or by cosine squared, we are able to derive the other two. So we also have tangent squared theta plus 1 is equal to secant squared theta. Again, really, this is the one to know, because if you know how to divide sine squared theta, cosine squared theta, and you know your reciprocal identities, you'll be able to come up with the other two. So also we have cotangent squared theta plus 1 equals cosecant squared theta. Okay, the sum and difference identities, we remember those as cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta, or cosine of the first times cosine of the second minus sine of the first times sine of the second. We also have sine of, or let's do the equivalent difference formula also. So then if we have cosine of alpha minus beta is equal to cosine of the first times cosine of the second, and we had a minus in the first one, we're going to have a plus in this one, so that's sine of alpha times sine of beta, or sine of the first times sine of the second. Now let's do sine. If we have sine of some angle alpha plus some angle beta, that's the same as sine alpha cosine beta, sine of the first times cosine of the second, minus cosine of the first times sine of the second. And then if we write the difference version of that, we have sine of alpha minus beta, that's equal to sine of the first times cosine of the second minus cosine of the first times sine of the second. Again, the more important ones to remember are the sums, because the difference is just going to be the opposite version of that. So last one we have is tangent of alpha plus beta equals tangent of the first plus tangent of the second, all over 1 minus tangent of the first times tangent of the second. And then for this one, we're just going to have the opposite, because it is tangent of alpha minus beta. That's going to equal tangent of the first minus, because it's the opposite, tangent beta all over 1 plus, because it's the opposite, tangent of alpha times tangent of beta. So those are the sum and difference. Again, for this one, the great ones to remember are the sum, because the difference is just going to be the opposite. So double angle identities. We remembered that we could derive these using our Pythagorean identities and our double angle identities. So, or I'm sorry, just our sum identities, excuse me, double angle identities, we're just using our sum identities. So we have sine of 2 theta. If you remember those sum identities, you can say theta plus theta and come up with these is equal to 2 sine of theta cosine of theta. Cosine of 2 theta is equal to cosine squared theta, minus sine squared theta. And then tangent of 2 theta is equal to 2 tangent theta all over, let me leave myself some room, 2 tangent theta all over 1 minus tangent squared theta. And again, you can go back and look at how we derived those in the last video. And the last one are these half angle identities, which is sine of theta over 2 equals plus or minus, depending on what quadrant you are in for that theta, radical 1 minus cosine theta all over 2 cosine theta over 2 is equal to plus or minus radical 1 plus cosine theta over 2, and tangent theta is equal to plus or minus radical 1 minus cosine theta over 1 plus cosine theta. So that's really all the important identities that you need to know from this chapter.